All right, students, in today's lesson, this one's going to be much more simpler than the last few assignments that we've been doing, where we had to use different tools like Desmos and the calculator to get our factors and everything. These are what we call special cases, and there's two different kinds. One is for a binomial, and one is for a trinomial. Well, the first one with the binomial, well, I call it the difference of two perfect squares, and it's in the form of a squared minus b squared. Okay, so the reason why I call it the difference of two perfect squares is, number one, it's subtraction, and we're finding the difference between one perfect square and another perfect square. Well, whenever this situation arises, whenever you can recognize this, you can very speedily factor it. It's the square root of a squared and b squared, which is a and b, and then you have two different signs in your parentheses. And so looking right here at this example, 9n squared minus 1, 9 is a perfect square. Its square root is 3. And n squared is a perfect square. Its square root is n. And the square root of 1 is 1. So if you take the square roots of each of those, you get 3n and 1. 3n plus 1, 3n minus 1. Booyah, it's factored. You're done. You just have to identify the perfect squares. Now, anytime a variable is squared, it is a perfect square. The square root is just your base. All right, but here's the thing. It has to be the difference. Must be subtraction. Must be subtraction. If it's addition, it doesn't work that way. Subtraction. I can't spell subtraction. Now, here's the reason why it factors out like this, but you only have two terms, because we had been factoring trinomials, three terms. If I were to multiply this back, I would get 9n squared minus 3n plus 3n minus 1. When you have the same thing in the parentheses and the only thing different is the sign, it cancels out those middle terms. You get a negative 3n and a positive 3n, so you're left with 9n squared minus 1. But that's the purpose for the for only having two terms there. So I just wanted to show you that as far as factoring goes, this is so easy to do. All right, now in this situation, only two terms, it is subtraction. They have a common factor, and remember, no matter what, take out your common factor first. So our common factor is 6, and that leaves us with an a squared minus 4. An a squared minus 4. Now, a squared is a perfect square. It's a times a. 4 is a perfect square. It's 2 times 2. So we've got a and a in our first positions, 2 and 2 in our second positions, and we're done. We have it factored. All right, now then, a perfect square trinomial. These might be a little bit more difficult to identify, but if our first term and our last term are perfect squares, and the middle term is the sum is twice a times b, then we have a perfect square trinomial. But this is what I always look for. I always look and see if those are perfect squares right there. And if their square roots multiplied times 2 give me the middle term, you're good to go. But here's the catch. That last value has to be positive. This term, your middle term, can be positive or negative. If it's positive, then you're going to get the same thing in parentheses. You're going to have a plus b, a plus b. And since those are both the exact same, we condense it into the one factor squared, because this means a plus b times a plus b. Now, if that second middle term is negative, subtraction, then our parentheses are going to both be subtraction. and we can write it as a minus b squared. So we just kind of have to identify if we're going to use some minus signs or plus signs. Now, very different than the difference of two squares. The signs are different. Here, our signs are the same. Okay, so let's break this down. 4, 36, and 81, they do not have a perfect square. But 4r squared is 4r times 4r. 81 is 9 times 9, so there's our perfect squares. And let's see, what is 4 times 9? You get 36, and we get those r's, and so we are good to go on that. So we have 4r plus 9, 4r plus 9. And then you can write that as 4r plus 9 squared. All right. The second example, this one we have a subtraction sign. Okay, but we also have terms. This is not a perfect square, 27 nor 48. But all of these have a common factor of 3. So I'm going to factor out a 3 out of each one of these terms. That leaves me with a 9m squared minus, let's see, what is 72 divided by 3? Let's go up. 72 divided by 3, I had it written down as 24. So this is a 24mn. And then we have 48 divided by 3 is 16. So we have 16n squared. All right. Now, let's go ahead and take a look at our coefficients. Perfect square. This is 3m times 3m. This is a perfect square, 4n times 4n. So these are what are going to be placed in our parentheses, 4n and 4n. Doesn't matter that these are different variables. Remember, they're perfect squares. We've got a minus sign and a minus sign. And then our coefficient in the very front, our greatest common factor there, our GCF, we can't forget about it when we're finishing this up. Then we can write our final answer down as 3 times 3m minus 4n squared, because our two sets of parentheses are identical. They are the same thing. So this is a quick way to factor. If you don't recognize it, no big deal. You just factor by grouping like we have been doing. But if you can identify it, you're saving yourself a lot of time on these trinomials. This one, however, you do have to identify it, but I think it's a little bit easier to identify. Once you take out your common factor, if these are perfect squares, it can keep going. All right. So you have an assignment to do, and you're just going to do problems 1 through 10 on the front page. These examples that I did for you were problems on the back page, but only numbers 1 through 10, just for practice.